this is slope-intercept form. We want it to be general form. General form has everything on one side of the equal sign. So if I want to change this to general form, I need to move the y. How do you move something from one side to the other? You could do an opposite operation. This is like a plus y just sitting by itself. So we need to just subtract y from both sides of the equal sign. Y minus y would give me 0. On the other side of the equal sign, I like to keep the x's and the y's in the same order as the formula. So I would have 5x. I would now have a negative y. And I would now have a negative b. The order you could change it, and it'd still be the same thing. It's just preferred to have the y in that order. I just like it that way because it follows the formula. All right, it's equal to 0. So that's the first thing you need for general form. We're good. The second thing, you check all your values. Do you have any decimals? None. Do you have any fractions? No. So you're good on that part. They're all integers. The last thing you look for is your a value positive. It is positive 5. That thing is in general form. No decimals, no fractions, a value is positive. B and C are negative, but that's okay. All right, second question. We have, again, slope-intercept form. Y is by itself. We want general form. So that means all the things have to be on the same side. To do that, I move the y by subtracting the y. That gives me 0 equals 2x divided by 3 minus y plus 7. That is now general form because it's equal to 0. Everything's on one side. Now you go through your checklist. Are there any decimals? No. Is there a fraction? Yes. There is a fraction, and that's not allowed. So you need to get rid of that fraction. The best way to get rid of fractions is to multiply by whatever you're dividing by. So if you look at your question, this fraction means I'm dividing by 3. So if I want to get rid of a divide by 3, I need to multiply by 3. And what you do to one number, you do to all the numbers. That's how it balances itself out. And in math, you can't just operate on something without having some sort of balancing out. So I need to multiply everything by 3. Including the 0. Not that it does anything. It's just a good habit to make sure you're doing it to every side, every number. 0 times 3 would still be 0. When I have this, the 3 times 2 divided by 3, I can actually put it in my calculator like that. I can go 3 times the 2 divided by the 3. Or you can just know that the 3's cancel out, each their own. Okay? But if you want to calculate it properly, 3 times 2 divided by 3. And it'll tell you that it's equal to 2x. Minus 3y. Okay, imagine there was a 1 in front of that y, so 1 times 3 would be 3. Plus 21. Yep. All right, you're out of fractions now. So the last thing to look for is, do you have a negative a value? You don't. It's positive 2. That thing is general form. All right, last example. You have an equation. Again, it's in slope-intercept form. This is y equals, and there's no brackets. So that's slope-intercept. We want general form. To get to general form, we have to move everything to the same side. We subtract y. So it's colored minus y minus y. That means 0 equals negative 1 over 4x minus y plus 3 over 5. Notice how I wrote it like negative 1 over 4 in front. I could also write that like those mean the same thing. Right? Remember, you could write the x on top of the fraction if you wanted, just like they did in the blue one. You look at the second question, it was 2x divided by 3. They could have made that 2 over 3 times x. It means the same thing. All right, if you look at this, it's now general form because it's equal to 0. You go through your checklist. Are there any decimals or fractions? There are, so we got to get rid of them. This one's harder to get rid of. Because if I times everything by 4, it would get rid of that first fraction, but it wouldn't get rid of that divided by 5. If I multiply everything by 5, it would get rid of that 5 fraction, but not that 4 fraction. You could technically just do both. You could multiply by 4 and multiply by 5. That would work, technically speaking. But it might give you too big of a number. Okay? So the best thing you can do when you have multiple fractions, and you need to get rid of multiple numbers, like 4 and 5, is to figure out their lowest common multiple. Lowest common multiple means if you look at all the things that 4 could multiply to be 4, 8, 12, 16, 20, and you looked at all the multiples of 5, 5, 10, 15, 20, you want to pick the lowest number that they have in common. The lowest number they have in common is 20. That means if you multiplied everything by 20, it would get rid of both your fractions without multiplying by too big of a number. So I'm going to multiply everything by 20. This is where it kind of comes in handy to use that trick that we just did last time. You know how I said, like, if you cancel out 3s, that works? If you look at this, 20 doesn't just cancel out with 4. So to calculate that properly, we would go 20 times 1 divided by 4. And you would get negative 5x. Okay, so that's what I did. I did negative 1 times 20 divided by 4. Then it becomes negative 20y, and then it becomes plus. Again, with this one, I'm going to go 20 times 3 divided by 5. Which should give me 12. We did that to get rid of fractions because general form can't have fractions. All right, first thing, get it equal to 0. We did that. Second thing, get rid of fractions. We just did that. What's the last thing you checked for? Get rid of the negative a value, right? Your a, the number in front of the x, it cannot be negative. This one is. Get rid of it. We multiply everything by negative 1. Because that's what switches signs. Now, that's like the mathematical thing you do. That's the reason why what we do works. Or you just change all the symbols. So if you have a negative symbol and you want it to be positive, just change it to be positive, but you have to change all the symbols. They all switch. Okay? That's what multiplying by negative 1 does, is it changes all the symbols. So my final answer is 0 equals 5x plus 20y minus 12. That meets our criteria. Equals 0, no decimals, no fractions, no negative a value. All right. How these questions work going the other way. So that was converting into general form. Sometimes it might be useful to go the other way. So for instance, if you look at example 2, it says determine the slope and the y-intercept of the following lines. Well, slope, y-intercept, it would be really useful to have slope-intercept. When I look at my questions, they're not slope-intercept form. Those questions are in general form. General form tells us absolutely nothing. Does not help us. What does help us is slope-intercept form. So we're going to convert from general to slope-intercept form. Even though the question doesn't say convert, we're going to convert because it helps us answer the question. It's up to you to be able to figure out when it's useful to convert. That make sense? You have to be like, Slope-intercept means I should be in slope-intercept form. I'm currently not. I need to change it. To change it into slope-intercept form, you need to have y by itself. Right? Y on one side by itself. In this equation right now, the y is with everything. So we want to move it to the other side so it's all by itself. To move something, we do opposite operations. So if I have a minus 5y, what should I do? It's positive 5y. What you do to one side, you do to the other. That gives me 2x plus 25 equals 5y. Now, probably the biggest mistake people would make is they would now answer the question. And they say the slope is 2, the y-intercept is 25. Right? That looks like mx plus b. But this is not slope-intercept form yet. Why not?
Because the y by itself.
Because the y is not by itself yet. There's a 5 attached to it. So how do you get rid of that 5? You divide by 5. You're dividing because when there's nothing between a letter and a number, that means 5 times y. The opposite of times is divide. So you divide everything by 5, you end up with 2 over 5x plus 5 equals y. Now I can answer my question. The question was, what's the slope, what's the y-intercept? Slope equals 2 over 5, y-intercept equals 5. I couldn't answer that question until I got it in the proper form. And then it was really easy to answer. All right, for B, we've got the same problem. So we've got a formula. It's definitely in general form right now. ax plus by minus c equals 0. I want it to be in slope-intercept form, which means I want the y's all on their own. So I move them over to the other side by subtracting 2y. That gives me 6x minus 15 equals negative 2y. That's the stage people would say slope is 6, y-intercept is negative 15. Because it looks like mx plus b, right? It's a little deceiving right now. The key is to get y by itself. Right now I have negative 2y. That's being multiplied because there's nothing separating the number and the variable. The opposite of multiplication is division. So you divide both sides by negative 2. 6 divided by negative 2 is negative 3x. Negative 15 divided by negative 2 is plus 7.5. And now y is by itself. If you left 15 over 2 as a fraction, that's okay too. Okay. Okay. If you look at my slope in the first one, I left it as 2 over 5. If you look at my slope in this one, I changed it from a fraction to a whole number. That's because it divided evenly. If 2 over 5 divided evenly, I probably would have changed it. But it didn't. This one just does. That's why it became negative 3 and not 6 over negative 2. The question was, what's the slope, what's the y-intercept? So the answer is slope equals negative 3, y-intercept equals 7.5. Any questions about converting the slope-intercept form? Get y by itself, divide by the number. All right, example 3. A little trickier. It says the lines 3x minus 4y plus 8 and 5x minus 4ky minus 6 equals 0 have the same y-intercept. Determine the value of k. Same y-intercept. Do I know what either their y-intercepts are? I could figure out one. But both of these equations are currently in general form. Basically a useless form. I need to be in slope-intercept form. Because then I could actually figure out what the y-intercept is supposed to be. And in this first equation, I could actually calculate it, right? The second equation, I couldn't because there's a k there. We're going to try just to see what happens. We're going to start with the easy one. So we're going to find the y-intercept of that first equation. I'm going to move things up so you can see. So, I have 3x minus 4y plus 8 equals 0. I want to figure out the y-intercept of it. Yep.
It says they have the same y-intercept.
Yep.
So wouldn't k just be 4?
That would be true if all the other numbers had been the same thing.
Oh, okay.
But they're not. That's a good inference. If the other numbers were the same, then you're right. But because they're different, the y-intercept will have to be different.
Okay.
So I move my 4y over by adding it. Then I divide by 4 so that that number is all by itself. There, the y is by itself, that's slope-intercept. The reason that's useful is now I know what my y-intercept is supposed to be equal to. What's it supposed to be equal to? It's supposed to be equal to 2, right? In that equation, I figured out that the y-intercept is 2. The question said they have the same y-intercept. That means this should also have a y-intercept of 2. Now you could guess and check and put in a lot of numbers and do a lot of calculations to try to figure out what version of, or what value of k makes that work. Or you could solve this equation algebraically for its y-intercept. K is just a number. It's nothing special. We can treat it the exact same way we've treated every other question. To figure out the y-intercept, we get into slope-intercept form. That means to get y by itself. Right now, I have negative ky with everything else. I want to move it to the other side. How have I been moving everything else? You look at this one over here, and this had negative 4y. To move it, I just added 4y. If this one's negative ky, then I should just add ky both sides. And that would move it, right? Just like the negative 4 did. It moves it over. That gives me 5x minus 6 equals ky. This isn't slope-intercept form yet because there's still something attached to that y. Look at the other questions. What have we done to get rid of that number next to the y? We've just divided by whatever that number is. So in this case, what should we divide by? Divide by k. And you're doing everything the same, just like it's a number, it's a letter, right? It's the same thing though. It just represents a lot of numbers. This now becomes 5 over k x minus 6 over k equals y. If I gave you that equation right now, and I said, what's the y-intercept? This equation. The y-intercept would be negative 6 over k. But we just don't know what k is. Correct? What do we need that y-intercept to actually equal? 2. We need it to equal 2. Because all these things were supposed to be the same. So now, you could probably look at that, and some people could figure out what value of k would make it work. And I can hear people doing it, I see people doing it. And some people might just see, well, if I need it to be 2, 6 divided by 3 is 2. So that means the answer for k must be negative 3, because I got to cancel the negative signs. But mathematically, what you should do is say, these y-intercepts need to be the same. That means 2 should be equal to negative 6 divided by k. and you're going to cross multiply and then divide the other number. I'm going to multiply or move the k up there, kind of like we used to in trig. Move the 2 down there, so that k equals negative 6 divided by 2. K equals negative. That's the value that would give you the same y-intercept for both equations. That is a very, very hard question. If we gave you that question on a test, we would call that a standard of excellence question. So that would be like one of the harder ones for you to work your way through. As I did it with you, it might not have seemed that hard, right? It might have been like, okay, I understand everything that's happening. But you also had somebody kind of leading you, right? To see that on your own the first time might have been like, holy crap, what do I do? There is practice questions like that in your book. You might get one on a test like that if we're trying to do something hard. Anybody have any questions about that? How many people feel like they understood what was actually happening on that question? Okay, 7. That's pretty good. That's a hard question, right? It's a lot of math. Biggest thing you need to draw from this slide is if you want to figure out slope-intercept, change it to slope-intercept form. No matter what equation you have. All right, last one. This one says, which of the following is, or are, perpendicular or parallel to this line? Basically what they're saying is, are these lines perpendicular or parallel to that line? We're going to do a quick review, for 2 seconds, on what it means to be perpendicular. If you have 2 things that are perpendicular, 90 degrees, what does that mean about their slopes? We had a name for it, don't we? Opposite and different symbol, we call that negative reciprocal. That means if you had something like 2 over 3, its perpendicular slope would have been negative 3 over 2. Like that's what perpendicular means, so that's just a review. Parallel lines are 2 lines that never cross. Oh, those 2 definitely cross. If 2 lines never cross, what does that mean about their slopes? They're the same. Perfect. So the question is asking you, are these slopes perpendicular or parallel? That means they're asking you, are their slopes the same, or are their slopes negative reciprocals, or are they neither? You look back at the equations they gave you. None of them are in slope-intercept form, so you don't know any of their slopes. They're all in general form. So you're going to have to convert them from general form to slope-intercept form. I'm going to do all 3. I'm going to put the question one in the middle. And then I'll do part I in red over here. And I'll do part double I over here. If I want to figure out if they're parallel, I need to figure out what their slopes are. Only way I can check their slopes is if I'm in slope-intercept form. So I need to change all of these into slope-intercept form. We'll start with the red one. That means I need to get the y by itself. So let's subtract 3y from both sides. That puts the negative 3y on the other side. I then have to somehow get rid of that negative 3, so I divide everything by negative 3. That gives me negative 2x plus 1 over 3 equals 1. Does anybody have any questions on converting to that one? I know you're ready to take it down. I followed the same process. Move the y's over, divide by the coefficient. What's the slope on this equation? It's negative 2. Make the number attached to the x is the slope. if I do that blue one? I need to add 2y to both sides. Add 2y to both sides. That gives me 4x plus 9 equals 2y. I then have to get rid of the 2 so that y is all by itself. I have 2x plus 4.5 equals y. What's the slope of this line? It's just 2. The last one in green, I need it to be slope-intercept form, which means I need the y's to be on one side. So I subtract 2y from both sides to get the y's on one side. And then I have to divide by negative 2. Dividing by negative 2 can be a little tricky in this one. So if you're looking right here, you have x divided by negative 2. What's the number in front of that x?
Where did you get the 12? The negative 12?
It was part of the question. What's the number in front of that x? It's 1. So that's like having 1 over negative 2x. Some people might want to write it like that so that they can easily identify their slope. Their slope equals 1 over negative 2. That's 3 really fast conversions. Probably a good page to look back on if you ever want to convert into Y-intercept form. So that's 3 all in a row with the workshop. Yeah, Bryce?
If you want to, you put the one I think that we all.
Perfect. So if you look at your slopes in red and in blue, they're both just negative 2 and 2. It might really help you to divide by 1. Because that really helps remind yourself that when you're flipping an exponent or flipping things for negative reciprocals, that there has to be a 1 there. We're not done yet because we haven't answered the question. The question was, which are perpendicular or parallel? So, if you look at the red one and compare it to the blue one, are they parallel, meaning they have the same slope? Are they parallel first? No. They're definitely not parallel because this one's negative and this one's positive. Is it perpendicular? They're opposites in the sense that one's negative and one's positive, but it's not flipped. So this one is neither. If you look at the blue one and compare it to the green one, that's what perpendicular should have looked like. Because that one is different symbol and flipped. That can be tricky, right? So make sure it's negative and flipped. All right. Hopefully tonight it rains.